66 million years ago, a rock the size of Mount Everest slammed into the Yucatan Peninsula with the force of 10 billion Hiroshimas. It turned the sky into an oven, triggered tsunamis a mile high, and ended the reign of the dinosaurs in a single afternoon. For millions of years, the universe has been playing a high-stakes game of cosmic billiards with Earth as the pocket. And until recently, we had no way to play defense. But if that same asteroid showed up on our scanners today, we would not just be sitting ducks waiting for the fire to fall. We are the first species in Earth's history with the brain power and the hardware to actually hit back. The biggest challenge isn't the hit itself. It is the warning. If an asteroid like Chicxulub is only spotted weeks before impact, we are done. Even our best tech cannot move something that heavy that fast. But thanks to the Near-Earth Object Surveyor and our global network of telescopes, we are getting better at spotting these killers decades in advance. If we have 10 or 20 years of lead time, we no longer need a miracle. We just need physics. The first and most proven method we have is the kinetic impactor. Think of it as a cosmic game of tag. In 2022, NASA actually proved this works with the DART mission. We slammed a vending machine-sized spacecraft into a moonlet named Dimorphos at 14,000 miles per hour. It did not blow the asteroid up. And it was not supposed to. It just gave it a tiny nudge. At millions of miles away, changing an object's speed by just a fraction of a millimeter per second translates to missing Earth by thousands of miles years later. For a dinosaur killer, we would just need a fleet of these impactors. Essentially a swarm of kamikaze drones hitting the rock, one after another, until its trajectory shifts out of our orbital path. If the kinetic approach is too weak for a massive planet killer, we have the nuclear option. Forget the movie Armageddon, where they drill into the core. That is a terrible idea because you just turn one bullet into a shotgun blast of radioactive debris. We would use a standoff blast. We would detonate a massive nuclear warhead a few hundred meters above the asteroid's surface. The intense X-rays and heat would vaporize the outer layer of the rock, turning that material into a jet of gas that acts like a rocket engine, pushing the asteroid in the opposite direction. It is the most energy-dense solution we have. And against a 10-kilometer wide rock, it might be our only hope for a quick course correction. For a more surgical approach, we could use a gravity tractor. This sounds like science fiction, but it is just basic Newtonian gravity. We would fly a very heavy, massive spacecraft right next to the asteroid and just stay there. The tiny gravitational pull between the ship and the rock would act like an invisible tow rope. Over several years, the ship's engine would slowly pull the asteroid away from Earth. It is slow. It is steady. And it is incredibly precise. We could also look at solar sails, or even painting the asteroid white, by changing how the rock reflects sunlight or how it radiates heat. A phenomenon called the Yarkovsky effect. We could let the sun do the heavy lifting of pushing the rock out of our way. We live in a unique moment in geologic time. The dinosaurs had no space program, no telescopes, and no way to understand the fire in the sky. We have all three. We are currently mapping the heavens and building the shields that will ensure we do not go the way of the T-Rex. We are no longer just victims of cosmic chaos. We are the first generation of humans who can actually secure the future of the planet against the largest threats in the solar system. The sky is no longer falling. It is being monitored. If you want to keep learning about how humanity is mastering the final frontier and protecting our home, make sure to subscribe and hit the notification bell for more deep dives into the future of tech and space.